Hello, my name is Ricky White. I'm going to be doing my project on a big climate risk topic, which is the ozone depletion. So, first of all, what is the ozone? The ozone is the upper level of the stratosphere that protects the Earth from UV radiation. In the last 50 years, it has been discovered that the ozone layer is thinning. As you can see in this picture to the left, the sun emits ultraviolet radiation, UV radiation. When there is a thinning of the layer in the ozone, UV radiation is able to get into past the layers to the section of the earth where we live in. It's called the troposphere. It's the reason this process is the reason why it's they say we should wear sunscreen when we're going to be in a lot of sun or on the beach laying out soaking up the rays because there's an increased risk of skin cancer from the UV radiation that is emitted and able to pass the ozone layer. In the 70s, scientists discovered that the stratospheric ozone layer was thinning because of the use of chlorine and bromine. These substances are called ozone depleting substances. They are also potent greenhouse gases. During that time, these ozone depleting substances were common in aerosol sprays, plastic foams, the refrigerant in refrigerators, and car and building air conditioning units. How does the ozone depleting substances exacerbate climate change? Well, they're potent greenhouse gases. So they can increase the climate of the world, of the earth, of the temperatures, um, and the possibility for the creation of newer ozone depleting substances is great due to the increasing in amounts of greenhouse gases. All of these greenhouse gases in general, ozone depleting substances, can alter and break down the ozone layer. Geographically, Antarctica is a great example of ozone depleting. So there is what is called the ozone hole that is specific to Antarctica. It's the severe, as in its quote, the severe depletion of the Antarctic ozone layer, known as the ozone hole, occurs because of the special atmospheric and chemical conditions that exist there and nowhere else on the globe. So it's basically like in here in Antarctica, the rate of ozone depletion is accelerated due to the lower winter temperatures, which causes these very, very pretty clouds here, the polar stratospheric clouds. In these clouds, a lot going on. It's very cold. There's whipping winds, which all cause the chlorine and bromine reaction from those chemicals that are already there in the stratosphere. Um, this reaction of the chlorine and bromine causes ozone depletion. So geographically, this is very big here at Antarctica, and it kind of shows on a large, like on a more visible scale, what is going on in the ozone. So ozone depletion effects on humans. The UV radiation that gets past the ozone layer can cause an increase in skin cancer, the incidence, and the mortality, which I will talk about more in the final. The UV radiation also causes an increase in cataracts, squamous cell carcinoma of the cornea, and or conjunctiva of the eye, and and other damages to the surface of the eye. UVA radiation that passes through the ozone depletion areas has a great effect on plants as well. The UV rays can affect plant growth, reducing agricultural productivity. Also, they can alter the biomakeup of aquatic life, most specifically for phytoplankton, because they obtain their energy directly from the sun, but this can also trickle down into other aquatic life that actually feed on the phytoplankton to gain their energy. Work has already been done to help heal the ozone layer. So the biggest thing is the Montreal Protocol, which was a treaty signed by 197 countries in 1987 to phase out consumption and production of ozone depleting substances. Um, in this quote, it says the Montreal Protocol has proven to be innovative and successful and is the first treaty to achieve universal ratification by all countries. So this protocol treaty has really curbed the healing and accelerated the healing of the ozone layer um, in a lot of ways. And so all these countries have really phased out the production of these ozone depleting substances, which has really healed the ozone layer. But more can always be done. So, what can be done? There should be continual measurement of individual countries' compliance with existing restrictions and reducing ozone depleting substances. This can be done by measuring and recording yearly ozone depleting substance emissions. The biggest thing that can be done with this is to have committees for all these things in these different countries that can measure and record and monitor their own country's emissions. Also, there should be surveillance of the market and research for any emerging new chemicals or technologies that can pose a threat to the ozone layer. As you know, with increasing time, with years, more chemicals will be developed, more technologies will be developed, and we just need to be on top of what is being done to make sure that ozone depleting substances don't reemerge on the market and into the air. Also, there should be a committee creation for the monitoring of proper disposal of banks of ozone depleting substances. So, of ozone depleted substances, they were stored. And so, there needs to be a committee that needs to make sure that they are being disposed of properly and that they aren't making their way back into the atmosphere. So I put it here, every country's rate of compliance with properly disposed ozone depleting substances can be measured by the committees in which they create. So it really should be personal to the countries, that they should be able to monitor their own um, disposal, making sure that they are doing the right thing. So, lastly, continual monitoring and measuring for improvement in the ozone layer, is a big one because we want to make sure that we can see the efforts that are being done, seeing that there's a positive impact being done to the ozone layer and that it's benefiting from what is being done. So, thank you. I'll be going over more of the mitigation in the final.